Hey there. This is the second half of the video for the notes from section 6.8. We did that on Friday, February 28th. So again, we're going to use the graph of this function. And so this is the part that I explained incorrectly during class. So what I want you to notice here is that this ordered pair here and this ordered pair here, these don't count as local extrema because we don't change behavior. If you decrease and level out, that doesn't count as a local extrema because of the definitions we're using. So this leveling out here, that doesn't count as a local extrema. That doesn't count as a local extrema. There has to be a change in behavior from increasing to decreasing or vice versa. So this function has none, no local relative minima. So this is not applicable because there's no x value because there's no local minimum. There is a local maximum of y equals 2 that occurs at x equals 5. So just take a moment to stop the video and make sure that you feel comfortable with why we're calling this a local maximum, but we're saying that there's no local minimum. And if you want, I'm happy to explain it. I'll be explaining it again in class because I want to make sure that I convey the correct information. So then this function will be increasing from from 3 up to 5, and that's the only interval where this function's increasing. And we talked about in class how functions increase or decrease on open intervals, and the definitions we're using, we say that a function's constant on open intervals as well. So this function's decreasing on negative infinity up to -1, and then we're decreasing again from 2 to infinity. And again, because this says intervals, we're just going to separate the intervals with commas. If you were asked to use interval notation, and so I may have said x equals 5. I may have said x equals 2. I meant x equals 5. And now f of x equals 2, so that means we draw a horizontal line at y equals 2, and then we figure out where we intersect the graph. So definitely at x equals 5. And then also, looks like around -2.5. So again, to solve f of x equals 2, you can do this graphically, draw a horizontal line at y equals 2 and find intersection with the graph. And there might be 1, there might be 2, there might be 5, there might be none. Now f of x is strictly positive, so that means we're going to find the zeros, and so we'll call that -2.25. So f is positive from negative infinity up to -2.25, and then we'll just list these intervals and separate them with commas. And so then all the y values are negative here, but then when we get to 3.5, we're positive again. And then let's see, that continues until we get to like 6.5. And that's it. Those are the only intervals in the domain where the y values are positive. And now notice that we've got f of x is less than or equal to 0, so we want to find the spots where f is equal to 0 or less than. So -2.25, and then this is going to be closed intervals because we want all the values where this happens. And then -2.25 up to positive 3.5, and that's it. And then, again, we're using closed intervals here. Because f of negative 2.25 equals 0. And f of 3.5 equals 0. So again, I know that this material is challenging. Please don't ever be shy to ask about it. I'm always happy to answer any questions you have, and I hope this was helpful. Thanks for watching.